So we're starting sort of round 2 of revisiting all the content in the course. We're going to do a little bit of algebra over the next few days. Again, this is like skill building. A little bit of it will be review, but we're going to do some new stuff as well over the next couple of weeks, and some really new stuff sort of close to the end of it, factoring, which will anyway be a skill that we're going to need down the road, and then we'll start getting back into some of the actual content stuff. So exponent laws. Here's the rule. When multiplying powers with the same base, you can rewrite as a single term by adding the exponents. That's the kind of rule that a lot of people probably don't memorize, or you read it and you don't really know what it means. And there's a little example here of how you apply it. These are the kinds of things we really like in math. Like math teachers like this kind of stuff because we understand it, and it is a general rule for everything. But let's take a look at maybe a better example that will help this. Like, even if you don't write this down, all of it just yet, you really, really want to think about this at some point today or over the next couple of days. Today will probably be fairly easy. People are usually good at it. Tomorrow will probably be fairly easy. But then we're going to start to mix some different ideas together, and that's when people really start to have a hard time. And it's kind of one of those things where I find people either get it or they don't. So if you think about what we're doing today, in particular the multiplying part, and if you really think about it and really spend some time to make sure you understand why this works, then hopefully you won't get it mixed up and make mistakes down the road when it starts to get more complicated and starts to get all mixed up. Okay, because it is straightforward and it's fairly clear, but understanding why really helps in mathematics. A lot of people don't bother getting to that point of understanding why. So let's take a look at a specific example. This uses numbers. It's just helping us illustrate because we're not really going to be doing it with numbers as much. So it's just to help us kind of visualize and understand what's going on. So I'm just going to rewrite this with my colors. 4 to the 3 times 4 to the 4. Now we have to understand what exponents means. Who can tell me what 4 to the 3 means? It's not 12. Why might people think it's 12? Adam, what does it mean? Right. But everybody in here can imagine how people will write that as equals 12. And it's not 12. Do it on your calculator. It's 64. 4 times 4 is 16 times 4 again is 64. Not 12. But even though people know that, they still will write 12 because your brain starts going fast and you make those careless mistakes, right? So be careful. That's one thing to be careful of. It means 4 times 4 times 4. So if I expand this, this is just to illustrate. This is not how we solve these problems. This would look like this. Okay, so that's equals. So this equals 4 times 4 times 4 times. And so 4 to the 4 is going to be 4 fours. Times 4 times 4 times 4. But the fact that half of them are red and half of them are blue doesn't matter. Now, it's just 4 times 4 times 4 times 4 times 4 times 4 times 4, right? That's all it is. So what is this? What's another way of rewriting this? Thomas? And so what does it work out to? 4 to the 7. 4 to the, and I'm going to write this again, we normally wouldn't, but to the 3, just this one time, we're going to kind of illustrate it this way. That's what it works out to, but I hope you understand why. And this is what I'm saying. Even after you start working, go back and think about this, because we're not going to do this every time. You're just going to use the rule that you take the exponents, the 3 and the 4, and you add them together. 3 plus 4 is 7. Same base only. What does that mean? The base is 4. Okay, so these two terms that we're multiplying together, 4 to the 3 and 4 to the 4, have the same base of 4. When I multiply those, you add the exponents. And there's your illustration of y. If you don't lose the y, if you remember that, then you won't get it mixed up. Sometimes we add terms together, sometimes we multiply them together, and people get mixed up when you change the exponent and when you don't. That's coming up down the road. So if you think about y multiplying these powers with the same base, that's why you add the exponent. If you think about y, then maybe, in the middle of a test, you're like, oh, which one is it? You can think about it, well, I remember that example, and I remember this is when you do it. Does that make sense? Any questions? Adam, do you have your hand up? No? Question? No? Okay, let's try another one. This one's very simple again. Same base. In this case, the base is x. Okay. What's the answer going to be? Who knows what the answer is? Anna? Yeah, x cubed, x to the 3. Very good. So that's how you would finish this question. You just write that. But if I'm going to illustrate it, so it equals x times x squared, which is, this is tricky because, so instead of using an x for multiplication, I'm going to use a different symbol that we use sometimes, which is just a dot. Okay, so don't get confused by that. So this is like x times x. That's why we use a dot sometimes, so it's not confusing between x's and multiplication. No, you don't. Like, I don't want you to, but I do want you to think about it and remember why. Instead of just memorizing the rule, if we understand why, then you can always go back and rethink about it. Okay, so there's 3 x's there, all multiplied together, and that's the definition of x cubed. Again, think about it. X cubed means x times x times x. X times itself 3 times. Whatever x is, we don't know. It's a variable, right? It's an unknown. Whatever it is, times itself 3 times. Okay, what about this one? Yeah, we can't do anything here. Some people start to get confused and make things up, so don't write this down. Mn squared, or they brackets, or I don't know what they do, right? Start making up things. But this example is to illustrate it's only when the base of the exponent is the same that you add the exponents. M and n are different. Now we would rewrite this that way, mn. Because 2 variables, there's a lot of stuff to review and think about here. 2 variables side by side means multiply. Stop me if there's questions. There's not a lot of examples, then we're going to do some practice, get you guys doing some practice. So this is the bigger kind. We're not going to see a lot of this year, but it helps us practice and think about these rules a little bit more. How do I multiply when there's a whole bunch of stuff in both? Adam? Yep. Very good. And then what about C? Nice. Add the exponents for B's, add the exponents for C's, right? You put the same variables together, basically. And what do I do with the numbers? I don't add them together. It's not negative 3 plus 6. It's multiplying. It's negative 3 times 6. What is the negative 3 and the 6 called in this case? Do you know? Close. Sometimes numbers are called constants. There's a different word we would probably use in this case. Thomas, what do you think? Very nice. Coefficient. So that's something that, it's just a term we use. You don't necessarily need to know it. I'll probably never test you on it. But we use the word coefficient a lot. And coefficient just means the number in front of a variable. So you multiply the coefficients together. What's 3 times 6? It's 18, so negative 18. You multiply the b's together. B to the 1 times b squared, so b cubed. And c squared times c squared, add the exponents together, is c to the 4th. Everybody good with that? Any questions? What about when you divide? Whoops, there's a mistake here. What about when you divide exponents? That should be m minus n. When you divide exponents or powers with the same base, you subtract the exponents. Division is like you're undoing multiplication, right? It's the opposite operation to multiplication. You're undoing a multiplication. So if you added when you multiplied, you're going to subtract when you divide. You're going to do the opposite. So again, if you want to watch, this one's not maybe as informative, and you don't have to write this down, but you can just watch. So this is like 6 to the 5 divided by 6 cubed, okay? Divided by, or 6 to the 5 over 6 cubed. We show it both ways, okay? So when I redo this, I'm going to do it the long way, the expanded way. 6 times 6 times 6 times 6. Make sure I get 5. Divided by 6 times 6 times 6. And this is why, to me, this one's not as clear, because we're not always as familiar doing this stuff. But when you have all multiply on top and all multiply on the bottom, you can divide numbers together, right? So these two numbers go together to make a 1. So they're gone. These two go together to make a 1. So they're gone. And I don't have another color here. These two go together to make a 1. And I end up with 6 times 6. That's all that's left on top. 6 times 6. Everything else is gone, which is 6 squared. Which is 36. Like this one and the one above it, 4 to the 7, well, that would be a big number. Sometimes you can give a number answer, but the whole point of this is just we're illustrating the idea.
Can you just minus the 3 off of 5?
That's exactly what you would do. But this is supposed to just show us why that works. But you wouldn't write out these steps, typically. Other questions? Okay, so let's try another one. So again, you're going to line up the parts that are the same with each other. So the coefficients go together, and that is not 28 minus 7. Again, that's where people get confused and make that mistake. And you might think you never will make that mistake, but then all of a sudden you do, because you got all sorts of other stuff going on in your head. So you got to think about why. That's just 28 divided by 7. There's nothing else to it. What's 28 divided by 7? 4. What's x to the 6 divided by x to the 3? Taylor?
3.
X cubed, right? 6 minus 3 is 3. So you subtract the exponents. And x to the 5, or sorry, y to the 5 divided by y. Yeah? Yeah, y to the 4. Why would you say, like, why is it to the 4? You're subtracting 1. Don't forget, y means y to the 1. Any questions? What do you think? All right. So try a few of those. Question 1 has some simple, straightforward ones, just the basic. You can probably get through them quickly. Question 2 will make you think a little bit more about this stuff. After you do question 2, you might want to check it with a partner, and then we'll get to question 3 after. It has some more challenging types, but if you can get through all of this, which I'm sure you can because there's a lot of time left in the class, then question 3 is a good one to practice with as well.